Okay, how do you want to set up, Nathan? Where does your bottle go? Okay. All right. Let's go ahead and have Nathan talk about it. And you guys can listen, okay? You have a lot to share.
I'm Nathan. I'm going to be studying tornadoes. What is a tornado? A tornado is a funnel-shaped rotating column of air, which when two air currents come from opposite directions in a thunderstorm or in a storm called a supercell, in it's hot air and cold air. And when they come together, it's causing the tornado to spin or vortex, which is another word for spinning motion. What does a tornado sound like? Some people say it sounds like a freight train or a jet engine. How fast do tornadoes move? We're not talking about wind speed. That's gonna be over there. We're talking about from one place to another, 10 to 20 miles per hour. Wow. How many tornadoes hit the U.S. in a year? About 1,200. Oh my gosh. Yeah, that's a lot. Here's me trying to work it out. There, I cannot see me.
Okay, sit on your bottoms. I'm going to stand up behind it and I'll hold it up.
Right there, it didn't happen at all. But right there, it happened. See the straight line?
What did you do?
It this.
Okay, show the class. Because they don't know what right there means and that it didn't work. Hold it up, Nathan. Can you do it holding up?
It's real hard for me.
Just faster. There, do you see it on the inside?
Tornado. See it? See it? Daddy, it broke again. No, water. Yeah, it's water.
What you're looking is you're looking on the inside. Hold it up, Nathan, so you can see it's going.
Tornado.
You see it on the top?
It's a.
Here, you do it again.
It's a tornado. Remember you did science fair that looks like that?
I didn't do one like this. Nathan did. You see it on the inside?
There's food coloring and glitter to help you show. Help you to see it. It's awesome. The spinning is getting smaller because it's
Because the water's draining down.
You did an amazing job on it.
Okay, so that's what Nathan did on the bottom. Okay, you keep going, Nathan.
And then this is called an EF scale. Why is it called an EF? It is called, it's named after a person who used to work at NOAA, which is an organization that studies tornadoes. And his name was Mr. Fujita. And when they upgraded it, it turned into enhanced. So it's called Enhanced Fujita Scale for short. EF scale. EF0, about 65 to 85 miles per hour. So it's kind of strong.
And that's about how fast Mommy and Daddy go on the highway, okay, kind of to give you an idea.
But the EF5 you have to be worried about over 200 miles per hour. And it's the biggest. For about 166 to 200 miles per hour. It's the second strongest. Third strongest, 136 to 165 miles per hour. To, I would say, 1100 to 135 miles per hour, and 189 to 110 miles per hour. Who studies tornadoes? But some people say it is a meteorologist or an that is for your scientists. Well, what should you do if there's a tornado warning? First, let me say what a tornado warning is. Don't be worried about this yet. You just need to be close attention to the radio and the TV because then the news will tell you. A tornado warning is when you should when they think a tornado is on its way. But a tornado watch is when they actually saw the tornado and you have to take cover immediately. But just in case they say it's kind of a tornado warning, keep a close watch on the news. I'm gonna go back. Now here's the quiz. A, stay inside. B, go to a basement. And if you don't have a basement, go to somewhere super low. Like the garage? Yeah, probably garage. C, keep away from windows. And D, all of the above. Now, probably not D, because you don't want to go somewhere high. You want to stay low to the ground. So I would probably do all these three things. Away from glass windows, go to a basement or somewhere low.
On something high, you could do your attic. I have two attics, one in my room and one on the ceiling.
Well, tell them why they don't want to go somewhere high. Why
Why don't you want to go somewhere high? Because the tornado, it's going to use more power at the top than at the bottom. So you want to take more cover at the bottom than you do want to have at the top. So stay away from attics and go low. If you don't have a basement, probably your garage would be the safest place.
Awesome. Is there anything else that you wanted to share about your science fair project about tornadoes?
Well, there's one thing. This is measuring the height. Like this EF scale is telling you the speed, the wind speed. But this tells you the height. Near zero, the smallest. Well, we have a mini version of a little tornado. Yeah, at the front of the playground, and where the buildings are, there's that little circle spinning.
Sometimes when it's really windy
Oh yeah.
and you go to at the end of the playground in the corner where the two buildings are, where
There's
Mrs.
so
Nikki
spinning.
Dawn's window and first grade window, there's a corner there and there's a lot of wind. All the wind gets trapped in that corner and it starts building a leaf tornado. I'll show you guys one day.
Oh,
So we
I
do guys have those
I
Okay, pause up.
I have not.
Judah, great to
Would
do.
you guys
Pause up.
like to see this one more time?
Yeah, I was going to ask you, but I can't.
Go ahead, Nathan.
Oh, it's big. That's because it gets smaller and smaller when the water drains down. Oh no, it's sparkling.
There. Nathan, how do you make that?
Oh, I used two bottles and a little tornado tube and some water and food coloring.
Asher, on your bottom.
And glitter.
Asher, you're right in front. You should be able to see.
I got some glitter stuck on when we were doing our snowflake. I got the bubble.
Awesome. Hang on.
I got little sparkles on my pants.
That happens. Glitter kind of just flies everywhere.
And then they was like, hey, maybe we can use this.
Well, now, will you tell the class how you made that in case they want to make it at home and learn more about tornadoes?
Okay.
Okay, Nathan's going to tell you what he
You
did.
need two big plastic bottles, about a little blue tornado tube, some water, food coloring, and then a little
you need to make a tornado of your own at home. And you know what, Nathan? Can I leave that in our science center for today? And if anyone would like to spin your tornado, could they?
Yes, and I was gonna ask, would anybody like to try it out?
I'll leave it in the science center because I want Adrian to present his science fair poster too. But we'll put this on the science table, so then that way during the day, they'll be able to use it. If you have any questions for Nathan, show him the way that Carter is showing him. I'll put this away. You may call on 3 friends that have their hands raised.
Calvin.
Tornadoes in water.
Wait, Calvin,
In water,
is it a question or a comment?
It's some.
Are you
something
sharing
that
more
will-
information?
Yeah.
Okay.
A tornado in water isn't called a tornado. It's called a whirlpool.
I knew that. That was supposed to be like a little example of a tornado. And I tried to make it. One time I tried to build out Legos at first.
Okay, call in 2 more friends. Thank you for sharing, Calvin.
Okay, Carter. I like your poster. Thank you.
Okay, last friend.
There it is. I love your poster. Thank you.
Thank you, Cheetahs. Why don't you guys go ahead and give Nathan a round of applause? He worked very hard. He did a great job presenting.
Thank you.